people are there over there. Yes. Okay. Now it is live.
Good morning, everyone. Am I audible?
Yeah, sir. You are audible.
Yes.
Yes.
Just a few minutes will start.
So let me know when I want to start the session.
Now with small introduction, you may start. So before bro, just check it on
Yeah,
YouTube.
it's live. You just go on.
Hello, Shashank. Please start.
Yeah, is it live on YouTube?
No.
No, just go to the channel and check it.
Now it's live. You can start.
So hello everyone, welcome to this amazing space week. We have planned lots of things like space talks and competitions here. Today we have Mr. Pon Maa Kishan with us, who is a very great personality, and is the founder and president at Society of Aero, mentor in charge at NITI Aayog by the Government of India. Also is editor in chief of Journal of Mechanical and Aerospace Engineering Research, and initiator and coordinator of ISRO's Outreach Network Center in Chandigarh University, assistant professor in Aerospace Engineering of Chandigarh University, and is the regional coordinator of NASA's Scientist for a Day, and is also a reviewer of Elsewhere's material proceedings. And he did his PhD in aerospace engineering at Chandigarh University. And he has done some research on hypersonic vehicles and two international conferences and five national conferences. And he also attended 8 national workshops and with one world record. Also, he awarded as I was awarded as the best research paper in 2019 at International Conference on Functional Materials, and he got Best Teacher Award in 2019 on Teachers Day at Chandigarh. And he is a member at American Institute of Aeronautics and Astronautics, and is also affiliate member at Royal Aeronautics Society in England, and is a member of National Renewable Energy Laboratory in USA, and is also a member of IEEE Nanotechnology. So today I request Mr. Pon Maa Kishan to so today I request Mr. Pon Maa Kishan to go on with the meeting. He's explaining you about the hypersonic technology demonstrator vehicle. Please listen to this amazing session and enjoy the session.
Thank you, dear. Thank you, ISRO fan clubs. And first of all, I heartfully thank you, Uman, for inviting me for this wonderful lecture. And I will start with wishing everyone a happy World Space Week 2020. So it is a wonderful week which we are going to celebrate. The entire world is going to celebrate the week, Space Week, dedicatedly for space science people, those who are very much interested and those who are working in the field of space science. So first of all, when Woman asked me to deliver this lecture, actually from our end also we are organizing some events and other lectures also. So I was having since they are doing their best in as an ISRO fan club. So I told okay I will do that for you on this wonderful day. So let's not waste the time and we will start the session with basic introduction of hypersonic technology and defense research. Most the same lectures I have given earlier also. So, but here I have added some few more details about DRDO's research which they have launched in the last month. Okay, so let's get into that. So the overview of this entire session is why hypersonic, and then we are going with vehicle design configuration of hypersonic, and the third option we are going with challenges, aerodynamics, and propulsion structures and stability of the aircraft. So not only aircraft, it is suitable for spacecraft also. When we speak about hypersonics, it is along with spacecrafts, aerospace, with the entire aerospace. So finally, with the future application, I will be concluding my session. Okay, right. So before that, we need to know what is hypersonic, because that is many of you may not be belong to aerospace engineering and you may be from various other department background. So for that, I have to give the basic introduction about what is hypersonic. So if you are going in bike or if you are going in car, you will be speaking about speed, right? Speed of the car is in terms of kilometer per hour, right? We will be using the term kilometer per hour, 100 kilometer per hour, 200 kilometer per hour. Like that, we will be denoting the speed of the vehicle, car or bus or even train. Okay. So, but when we speak about aerospace vehicles, they will be defining the speed in terms of Mach number. Okay. Although there will be a velocity of the aircraft or velocity of the missiles will be there, but generally the entire world will recognize a number called Mach ratio between speed of the object by speed of the sound. So speed of the object is like any vehicle which is moving in meter per seconds, right? And speed of sound we already know that approximately 340 meter per second at sea level. Okay, at sea level it is 340 meter per second, and as per altitude changes, the temperature is changing, and the speed of sound will decrease from 340 meter per second. It will slightly decrease as per the altitude increases. Okay, so we need to calculate the Mach number on which basis the aircraft speed is determined. Okay. So object of speed divided by speed of sound. So what this indicates is, suppose my aircraft is flying with the speed of 340 meter per second. Let's consider my aircraft is flying with the speed of 340 meter per second. So the speed of sound is also 340 meter per second. So 340 will get cancelled and we will be getting 1. So my Mach number will be 1. Okay. So when I say Mach number is 1, then it is coming under the classification of sonic region. So generally they will say as sonic region, but the image which I have shown here is representing transonic. Transonic means from the word itself you can understand that it is changing the phase from less than 1 to greater than 1. So when Mach is equal to 1 means it is said to be in a transonic region. Okay. But although the transonic region was given as 0.8 to 1.2, Mach number 0.8 to 1.2. But generally we can say Mach number 1 is sonic region. So from subsonic to supersonic it is getting transient. So that's why we are calling it as transonic. Okay. Right. So the Mach number less than 1 means if the speed of sound is 300 meter per second or 200 meter per second or 100 meter per second, of course, the value when we are dividing with the speed of sound, we will be getting less than 1, right? So Mach less than 1 is determined as subsonic speed. Okay, Mach less than 1 is determined as subsonic speed. So similarly, if the aircraft speed is more than 340 meter per second, let's consider 400 meter per second or 500 meter per second or 600 meter per second, then it is said to be supersonic. Okay, so depending upon the ratio of aerospace vehicle speed and the speed of sound, the Mach number is determined, right? So that's why if the Mach number is 5 times the greater than, if the Mach number is greater than 5, or we can say 5 times the speed of the aircraft is 5 times greater than speed of sound, right? Then it is called as hypersonic. Okay, so generally when we are speaking about hypersonic, right? So the aircraft speed will be 5 times the speed of sound, means you just multiply 5 into 340, right? 5 into 340, approximately 1600 meter per second, right? 1600 meter per second. Think about the scenario, 1600, 1700, right? Around it will become. So if an aircraft is flying for 1 second, it is reaching 1.7 kilometer, right? For 1 second, it is reaching 1.7 kilometer. Then think about how fast we will be traveling in the atmosphere. Okay, so that's what the every country in the entire world is focusing on hypersonic, where they have already done a lot of research in subsonic and transonic and supersonic. They are upgrading actually in subsonic and transonic and supersonic. They are upgrading, but only few countries are entering into the hypersonic research so that they can attain the future research. Okay, so India is also one among them who has tested hypersonic vehicle in the last month. Okay, so I hope you understand what is hypersonic right now. So let's get just summary of that. Mach number greater than the value of 5, that is 5 times the speed of sound. The aircraft or the missile or the rocket, whichever the aerospace vehicle, if the vehicle is having speed of 5 times speed of sound, if it is flying with 5 times speed of sound, then it is said to be hypersonic vehicle. Okay, so as I told, a hypersonic vehicle can be an airplane or missile or spacecraft. Okay, so any type of vehicle we can say it as a hypersonic. Even if we are speaking about a rocket, it is also flying with a Mach near about approximately 30 Mach number. Okay, so that it can reach the escape velocity also, right? So we need to generate that much. The aircraft need to fly in that much speed so that we can launch the spacecrafts into the outer atmosphere. So engines. So to attain this speed, right? To attain the speed of 1.7 kilometer per second, we need to have engine which is having the ability to make the vehicle to fly in the atmosphere. So for that, we will be using a turbojet. Turbojet is one of the aircraft engine, like how we are having in bike, two-stroke, four-stroke engine, petrol engine, diesel engine, like that. We are categorizing, right? So similarly, the aerospace, the aircraft engines as well as other rocket engines will be also classified in different type of manners. But we are not focusing on engine right now. We are generally speaking about what are the engines are available and what are the engines are used for hypersonic. So if you want to fly a hypersonic aircraft, right? If you want to fly a hypersonic aircraft, then we have to go with turbojet and ramjet combination, or turbojet and scramjet combination. Only with turbojet you cannot achieve the hypersonic speed. With turbojet engine you can achieve the supersonic speed. You cannot achieve the hypersonic speed. So in this scenario, what we are planning is we have to either take the combination of turbojet plus ramjet or turbojet plus scramjet. Okay, or either we will be using a solid bracket booster and then we will be having the scramjet. So that I will explain how this system will work. So I hope you all understood the basics of hypersonic flight, right? What is hypersonic and other factors. I hope you understood that. So the next thing is challenges of hypersonic flight vehicle. Okay. So this is the image which I have shown over here is the DRDO HSTDV, which was tested in the last month. So many challenges are there. It is not only for aerospace engineer, those who can solve that. Even the engineering with background of computer science or with the background of electronics or with the background of mechanical engineering, materials and science. So they can also are studying all the structural and all the components of the entire aircrafts, any type of aircraft, okay, either hypersonic or supersonic. But the mechanical people as well as the avionics and other branches also contribute to aerospace. Okay, but it is they have to need some knowledge where they want to contribute and how they want to contribute. So that's why this session is framed with regarding to that itself. Okay. So here you can see 4 challenges are there. One is aerodynamic heating. So aerodynamic heating means like it is not only for this HSTDV, it is suitable for all type of hypersonic vehicles. Okay. So when the hypersonic vehicle is in the air, and think about the speed 1.7 kilometer per second, right? 1.7 kilometer per second. So usually during a normal summer day, you try to go in a bike or in any manner, right? Or in open in the car and all. So if you are driving with 60 meter per second against the air, right? Against the air, you can feel the heat in your body. In your skin, you can feel the heat. So that is due to you are interacting with the molecules of air. The structure of your body is interacting with your with the surrounded air molecules. Okay. But for 60 meter per second itself, it is creating that much. Think about 1.7 kilometer per second, right? The hypersonic vehicle is going to fly with 1.7 kilometer per second. So at that scenario, the entire structure of the hypersonic vehicle will undergo aerodynamic heating, right? Thermal conduction, right? Thermal conduction in the outer surface, and it will be the air molecule will get stuck on the structure, and it will cause bow shock wave and other types of shock waves will be also formed, right? So that will create the aerodynamic heating. So this is one of the biggest problem in a hypersonic vehicle. So whenever we are designing a hypersonic vehicle and whenever we want to test the hypersonic vehicle, we need to ensure the structure as well as the shape of the vehicle, so that we will be generating less aerodynamic heating on the surface of our vehicle. Okay. So second one is structures and avionics. That you can easily understand structures, right? So whenever we are riding our bike at 100 km per hour, maybe maybe you might have tried that also in your young age. You might have tried that. So when you are going with 90 km per hour, some bike will start to vibrate, right? Some bike will start to vibrate. So for 90 km per hour itself, the scenario of a bike is getting vibrated means, think about when the vehicle, aerospace vehicle is flying with 1.7 km per second. So what will happen? The structure will get the structure of the entire vehicle, aerospace vehicle. Say the image I'm just showing with DRDOs, but you can keep any type of aerospace vehicle which is going to fly with hypersonic speed. Okay, either you can take with space shuttle, you can take with capsule, space capsule, right? So all those are going undergo to, and it will be classified under hypersonic only. So the structure will get vibrate. So we have to be very much sure the structure should withstand all type of forces acting on the surface, right? So it should not bend and it should not crack. So that things also need to be carefully maintained. So the third one is avionic system. See, all the instruments, right? All the electronics instruments. Even if you see, I hope you might have seen some Intel ad, right? Intel advertisements. So they'll be giving the advertisement like a person was sitting in the like Himalayan mountains and he will be working in his laptop. So the Intel ad will says that that system is very much ready to use at any environment, right? So, but generally, if you take any mobile or any electronic devices, if it is very much cold or if it is very much hot, right, then sometimes it won't work properly, right? So similarly, already we are experiencing an aerodynamic heating in the entire hypersonic vehicle. So the avionic instruments, the electronics instruments which we are going to keep in the hypersonic vehicle, it should not get affected by the thermal conduction, right? So if it is getting affected, directly exposed the electronics items, instruments, if it is directly exposed to the thermal heating, then the devices won't work properly, and it may affect the performance of the entire flight. Okay, because you know that the entire nowadays the modern aircrafts are having more electronic instruments, so mostly autopiloted systems are there, right? So if we lose electronics and all electronics instruments and all, then we have to go for manual drive only. So the manual drive will be difficult without any support of avionics and electronics instruments. Okay, so that is one of the biggest challenge in hypersonic vehicle, and we have to design in such a way that, and we have to place the location of the electronics devices need to be placed so that the aerodynamic heat won't affect the electronics instruments. Okay, so when we frame a structure which will save the avionic instrument, then the structure need to be designed in such a way that it will protect from the aerodynamic heat. Okay, so it is combination of all the things. Whenever we are saying challenges of hypersonic flight, it is a combination of all the things. Okay, so the fourth one is advanced materials. Of course, right? Coating, thermal coating is the thermal protection system is there. So the material which we are using along the structure, first of all, it has to be related with the aerodynamic heating. So the heat need to be, the thermal conduction need to be reduced by changing the materials, right? So thermal property of the material need to be studied. Various type of property need to be studied, although, and then the material is going to help for the structure also, right? So structure and protecting the electronic system also. So that's why I told all of these are a combination of challenges which is required for the development of hypersonic vehicle. Okay, so the fourth one is maneuverability. So for maneuverability, right? Maneuverability means to make the aircraft to go in a stable path. So everyone wants to fly in a steady level flight, right? Suppose if your aircraft or if your bike is going uncontrollable manner, or if your car is going uncontrollable manner, everyone will be afraid to drive a car, right? So all the systems and the engineers, those who work behind to develop a car or bike, they will mainly focus on stability of the vehicle. Okay, stability of the vehicle, so that it will you can control the vehicle as per your need. Okay. So that much ability will be done even in the car or automobile vehicles. So similarly, maintaining the hypersonic speed in a steady level, and we want to maintain without any ups and downs in the hypersonic vehicle, that will be a greatest challenge in the history of aerospace industry. Okay. So we need to do many research on this maneuverability. Okay. Because once there was a great legend called Otto Lilienthal. He has told that he has given a statement like, we can develop and we can design an aircraft, which is the easiest job. Designing an aerospace vehicle is the easiest job. It is a statement given by him. So designing an aircraft or aerospace vehicle is the easiest job. Manufacturing an aircraft and aircraft or aerospace vehicle is okay, something that they have done. They have done the work. But controlling the aircraft or controlling the aerospace vehicle, that is everything. Okay, because if I have designed, okay, 100 people are designing same type of vehicle. If manufacturing, then out of 100, nearly 30 people are manufacturing. But only less than 10 people will launch that, and less than 5 people will achieve the maneuverability. Maneuverability means controlling the aircraft. Okay. So that's why Otto Lilienthal, this statement was given around 18th century. 18th century itself, the statement was given. Okay. So think about that. If you are an engineer, those who are over there watching this live session, so designing any component is not at all going to be a grateful, because everyone is going to design. There are so many engineers, those who are focusing on designing of structures. Okay. But making that, manufacturing that, and then if you are testing and achieve the maneuverability, then it is everything. Okay. So this is a statement given by Otto Lilienthal. You just read about Otto Lilienthal. Great also. So as I told earlier, the hypersonic vehicle is divided into three reference classes. So three reference classes means one of the thing is winged re-entry vehicle, so which was space shuttles. So nowadays we are not using space shuttles, although we can study about space shuttle because that is most successful aerospace spacecraft which we have used for the longer period, like nearly 50 years of time span. We have used in space shuttle for going into space and re-entering into Earth atmosphere. Okay. So studying about space shuttle is always a great thing. So, but unfortunately, the American country they have stopped using space shuttle. So the second one is air-breathing cruise and acceleration vehicle. So the difference between winged re-entry vehicle and the air-breathing cruise and acceleration vehicle means, so this, otherwise they will call it a CAV. Okay. So what DRDO tested is a CAV vehicle only. So that means the hypersonic vehicle which is going to fly in the Earth atmosphere. Under the atmosphere, the hypersonic vehicle will fly. Okay, so that is what they are calling it as air-breathing cruise and acceleration vehicle. Whereas this winged re-entry vehicle is, it will go outer to space, either to international space station, and it will come back to Earth. Okay, so that's why it is called as re-entry. So the third option is uh, space capsules, or we can call it as non-winged re-entry vehicle. So this is not having any wing like space shuttle. So it is called as non-winged re-entry vehicle or space capsules. Okay. So this is what ISRO is going to do for Gaganyaan mission, which was scheduled in next year. I hope, hopefully, it will be done in the next year. So this type of space capsule is used for is going to be used by ISRO in Gaganyaan missions. Okay. But right now, according to this lecture, we are just going to see about cruise and acceleration vehicle, right? Air breathing cruise and acceleration vehicle, which was developed by DRDO Industrial Labs. So we will see some few factors about HSTDV. Initially, the design for airframe attachment with the engine was completed in year 2004. So the design was done in 2004 itself, but it took nearly 16 years to do the flight testing of hypersonic vehicle. Although they have done various types of testing earlier, but the successful flight for 42 seconds has been done. 20 seconds was done in the last month. Okay. So in May 2008, Dr. Saraswat, I hope you know that Dr. Saraswat. Right now, he has worked in NITI Aayog also as a chairman. So before that, he was a chairman of DRDO. So Dr. Saraswat, he told that we are developing a hypersonic vehicle that will be powered by scramjet engine. So I need to tell you guys the difference between scramjet and other type of engine also. So I'm having a slide with that. So I will explain how the scramjet and scramjet is different. So he given the statement in May 2008. So the design was done according to the later part. As the design was changed with scramjet engine. I hope I'm audible, right? I'm not.
Yes, sir, you're audible.
Yes, sir. Okay. So India, that is DRDO, needs some help in terms of testing the hypersonic vehicle. So for testing the hypersonic vehicle, at the time of 2008 and 2010, India didn't have proper hypersonic wind tunnels. Okay, so for that, India has requested Israel Aerospace Industries there, and as well as other Cranfield University of UK, and they have used Russia for testing the hypersonic model. Okay, so how the model will be, whether it will be stabilizing or whether it will be having any structural damage or other factors also need to be tested with wind tunnel testing with various collaborative projects. Okay. So apart from that, if you see the structure, right, it is having a 1 metric ton. So the weight is 1 metric ton and the length is 5.6 meter. So the length of the hypersonic vehicle is 5.6 meter long. The air vehicle under the construction features a flattened octagonal cross section with body, stub wings. So I will explain all this. So the wing shape and all they have given. So I will explain all those about that. And a 3.7 meter rectangular section air intake. So 3.7 meter rectangular section. Okay, so this is the air intake which was in the HSTDV. Okay. So these are the general historical fact about the design. So when we are considering materials, the airframe bottom structure, right? It is shown. The image is shown here is upper surface of the hypersonic vehicle. So the bottom surface and the wing and the tail section are made up of titanium alloy because to withstand the heat, right? To withstand the heat, so we have to use the titanium alloy over there. So aluminum alloy compresses the top surface. So the top surface is used with aluminum alloys. Various type of aluminum alloys there. Various type of titanium alloys there also there. So just I'm giving the summary of that what they have used. I'm not going in depth of each and everything because we are having only 1 hour time span. So the inner surface of double wall engine is niobium alloy and the outer surface is pneumonic alloy. So the inner surface of the engine, right? So here, yes. So the inner surface of the engine, right? So it was used with niobium alloy and the outer surface is pneumonic alloy, so that it can withstand the combustion taken place in the scramjet as well as the inlet speed, right? So it should not get distorted the flow. Okay. So then, due to technological denial of material for scramjet, a new program was initiated and the materials were developed in the house itself. That means, so this type of materials, niobium materials, alloys and pneumonic alloys as well as titanium alloys, it is not available widely in our country. So either we have to depend on foreign nations or we need to develop our own type of materials. So that was challenge in 2010 to do that. So, but later the scientists have worked and they have taken an initiative program and they have developed material which is used right now in the episode proteins. So, Victernal testing, as I told earlier, before doing some flying, we need to do testing. Previous testings need to be done. Okay. Like if you see, when a car is manufactured, they won't deliver the car immediately to the customer. They will do various type of testing, like whether the structure is working correctly or whether the tires is working correctly and the duration, endurance, as well as fuel consumption. All those factors they will be testing before coming into the customer, coming into the commercialization. So similarly, when we are doing a hypersonic flight testing, we need to do various types of testing. So you can see the time span, right? The design was completed on 2004 and 2020 also DRDO has tested that. So it is not finalized, it is tested. Okay. So don't think that we have successfully attained that hypersonic entire flight. There are so many testing phases are there. DRDO will do that, and within next decade, next 10 years, we will be surely having that hypersonic facility successfully for military purposes. So yeah, various type of internal testing has been done. So here you can see 1:16 scale model was kept in Israel aerospace industry. So I'm just representing the internal model. This is not the exact image of DRDO's hypersonic data. I'm just giving the hints how the internal test was done and where it was done. So for hypersonic, that means Mach number 5. So sorry, for greater than Mach number 5, we don't have proper facility in India at that time. Right now we are having some wintering in ISRO as well as in ISC Bangalore and the NIL also Sky. So the second test has been done with trisonic wind tunnel. Trisonic Mach 3, around Mach 3 we will be getting trisonic wind tunnel at India's National Aerospace Laboratory in Bangalore. Okay, so that test was done because when we speak about hypersonic speed means the aircraft is not only going to fly with directly, it won't fly with a hypersonic speed. Initially, it will start with subsonic speed. That is how we are driving. How we are starting to drive a bike or car. Initially, we are in zero rest position. then we are increasing our acceleration 10 km per hour, then we are increasing the accelerator, then 20, 30, 40, like that. We are increasing the speed, right? Similarly, when the hypersonic vehicle is started, it is not going to start with Mach 5 initially itself. Okay, so it will start with Mach less than 1 and less, then it will be changing to 1, then it will be going to greater than 1, and other factors also need to be done accordingly. Okay, any type of vehicle, it will be done and it will be started with 0 initialization, right? So that's why we are testing with supersonic speed also, and we need to do testing with the subsonic speed also, right? So only if you are focusing on hypersonic speed, and if we fail to start the vehicle itself, then that is the worst case, right? So we have to test with all types of Mach numbers, so that we can say that our aircraft is suitable for all types of speed, okay, whichever it is possible. Then later DRDO has come up that we should have hypersonic wind tunnel in India. So there was a budget was sanctioned, like rupees 3 to 4 billion rupees in Indian rupees. It was budget was developed for developing a hypersonic wind tunnel at the Hyderabad missile complex, okay, because this is very much needed for our India, but the cost estimation is very much high. So that's why the nation is, I think they will be under developing stage. So the fourth option, like a fourth point which I want to tell with internal testing is Saraswat, Dr. Saraswat in 2008 around, he has given the statement that our hypersonic vehicle can achieve the speed of Mach 12. So Mach 12 means near about 4,000 meter per second. 4,000 meter per second means 4 kilometer per second. Think about the speed. You just imagine for a second when you are blinking your eye, your that aircraft will reach 4 kilometer distance. So think about the speed, right? So that much ability, Dr. Saraswat has given that statement. Okay? Our hypersonic vehicle will achieve that Mach 12, but that is only possible with most advanced materials, as well as aerodynamic studies need to be done. Okay? Various types of problems are there. So we cannot explain in this 1 hour lecture. There are, that's why I have generally given what are the challenges in the aerospace. So in 2011, the scientists had 2 technologies for aerodynamics and aerothermodynamics and engine and hard structure through design and ground. So in 2011, all types of problems have been studied from 2004 to 2007. All types of problems, whichever I have given over here. So it was studied, and they have come up with solutions also, right? Technological need for those to develop that, they have come up with that. So then we will be coming to the flight testing. So flight testing is done on June 12, 2019. It was tested in the last year. 2019 also they have tested first time. It was tested in integrated test range, that is Abdul Kalam Island at Odisha. But there was a rumor actually which stated that India has not tested this, DRDO has not successfully tested this. But our Ministry of Defense has told that yes, India has successfully tested in 2019 itself. On 2020, that is in the last month, 7th September 2020, DRDO successfully tested the scramjet powered hypersonic technology demonstrator vehicle. So initially it was the vehicle cannot, the hypersonic vehicle cannot have self-starting engine. Okay, the scramjet and ramjet engines are not self-starting engine. So what we have to do is we have to launch in a rocket, or we have to launch with another help of aircraft which can fly with supersonic speed. So DRDO has used a solid fuel rocket, right? So it has the hypersonic vehicle, right? The image which we are seeing over here, the vehicle was placed in the cone section, right? And sometimes they will be saying payload fairing, they will say. Okay. So the payload fairing was separated at the altitude 30 kilometers. So when the rocket reaches at the altitude of 30 kilometers, So the firing was the booster when the booster reached 30 kilometers, then the firing was separated, and following the separation, the auto ignition sequence will start. Okay, so the hypersonic vehicle will start since it is already flying with Mach number in a hypersonic, since it is a solid booster which we are using. So when the fairing was open, then our hypersonic vehicle HSTDV also exposed to the hypersonic stream. So HSTDV cruise vehicle air intake opening will be done, and then fuel injection will be done, and ignition will be done, and then the vehicle will be tested. So only the hypersonic vehicle was tested for 20 seconds. Only for 20 seconds it has been tested, and the cruise vehicle achieved a velocity of 2 km per second. So the vehicle which they have tested in the last month, it is achieved a speed of 2 km per second. Okay, so which is one of the remarkable things, because whereas the other developed nations also they are doing and they are working with the hypersonic speed, and we are also reached that height in short span of time. Right? So when we speak about cruise and acceleration vehicle, the Mach number is 0.7, and it can be attained 0.0 to 7. So 7 in the sense, when we are using ramjet engine, then we can achieve the 7 when we are using scramjet engine. That's why Dr. Saraswat told that we are having the ability to reach Mach 12 because India is having scramjet engine. So using the scramjet engine, we can achieve up to Mach 12 also. Okay. So if you are having only ramjet engine, then we can achieve only around 7 Mach number. So the shape of the vehicle is slender shape. So if you see some rockets are we should not have conical shape and all. So the shape will be slender in shape. So that slenderness ratio of an aircraft need to be done for the CAV also. Yes, this is we are expecting the flight time should be long, right? See, if I want to travel from Delhi to Chennai, then it is approximately nearly 2,500 kilometers away, right? But if the aircraft is only flying for 20 seconds, means it is only covering 40 kilometers per second, right? So we need to test and we need to develop the hypersonic vehicle so that it can fly for long durations. Okay, so only 20 seconds is not at all enough. At least the vehicle need to fly for a minimum of 3 hours. 3-hour flight need to be done. That is very much useful for commercialization. So we have a long time of research and long time of dedication need to be done in the field of hypersonic, so that in future, upcoming future, we can achieve the long endurance of flight time. Okay. So another factor is angle of attack. So this is general term which was used in all type of aircraft and aerospace vehicles. Most probably the aeronautical engineer, those who are over there, they will know that. But if others are there, think about the air is flowing, right? So the vehicle is coming opposite. So the angle between the wing or the reference line, and the flow, air flow is given as angle. I'm just giving the basic thing, okay, and I'm just representing the basic thing. I'm not going in depth of angle of attack and all, because we are just giving the overall summary of hypersonic vehicle. So in case of hypersonic vehicle, the angle of attack need to be small. Yes, for CAV vehicles, that is cruise and acceleration vehicle. So when we are trying to build an aircraft to commercialize in the industry, then we need to be sure that we are having less angle of attack. So less angle of attack, our performance will be good. We can consider it. Okay, so there are many research factors are also there. I'm not going to that. So L by D ratio. L by D means lift to drag ratio. So lift force is which the aircraft is equal to at cruise level. Lift is equal to weight. Okay. So the force generated to overcome the weight, that is called as lift. And the opposite force, like whenever we are going in a bike or going in a car, you just raise your hand. You just raise your hand outside and you keep along the floor. Your hand will be moved backward, right? So your hand will be moved backward. So that's due to the lift and drag generation. Okay, so the resultant force of lift and drag generation, that your hand is moving backward. Okay. So otherwise, if you want to explain more about drag, you just keep a cardboard or any rectangular board in a bike, and if you are moving forward, the board will push you back, right? So the backward force is drag. Opposite to the forward motion, that force is called as drag force. So this is our major aim is to reduce the drag. Whenever we are designing an aerospace vehicle, our main aim is to reduce the drag. That is the main agenda of designing an aerospace vehicle will be. So some of the factors are there, which I have told earlier. That is slenderness ratio. Slenderness ratio is nothing but it is a ratio between half span and length of the aircraft. So half span means wing length, right? So full wing length is span. Half span is half either left hand side or right hand side. So that span divided by length of the aircraft. So from nose to tail, that will be called as length, and the span is from the wing left side to the right hand side wing, like total called as entire span length of the wing. But if you are speaking of a half length, then it is over. So centerness ratio should be less than 0.3 for CAV. For cruise and acceleration vehicle, it should be less than 0.5. Okay. So another important factor is I am showing in this slide two diagrams I have shown, right? Two images I have shown. So if you see the upper image, the wing shape. So the wing shape is different, and if you see the uh, bottom image, the different type of wing shape is there, right? So actually, this second image is called as double delta wing configuration, and this is called as OG wing. OG wing. So why this type of shapes are preferred in space shuttles, especially in supersonic aircraft? Also, this type of in Rafael as well as in all modern aircrafts. If you see the fighter aircrafts, supersonic fighter aircrafts, this type of shapes will be preferred actually. So why the necessity of double delta wing is preferred is, as I told earlier, the aircraft is not only going to fly with hypersonic speed, it has to fly with subsonic, supersonic, and hypersonic, and also it has to reduce, right? Because takeoff is there and landing is also there. So when we are taking off, it will be from 0 to 1 Mach number or 2 Mach number. When we are going to land, then it will be from 6 to 3 or 3 to 1 or 1 to 0. Okay, so like that only we are landing. So the study of low speed also need to be studied for any type of aircraft or any type of spacecraft also. Okay. So when the hypersonic vehicle is designed for, especially meant for hypersonic speed, when the hypersonic vehicle is coming to the low speed, that is subsonic speed, it has to maintain the properties. It has to have the stability of the aircraft should be there. Okay. So we should not focus on like, okay, chalo, I'm going to design a hypersonic vehicle. I'm just going to only focus on hypersonic speed. You should not do like that. You have to consider all the parameters, all the force parameters, and all the speed parameters, and you have to change or modify your shape of the vehicle accordingly. So that's why when the hypersonic vehicles are tested at low speed, to maintain the stability at low speed means subsonic speed, the delta wing, double delta wing, or this type of shapes are preferred for the hypersonic vehicles. Okay, so another few factors is, just now I have told about wing configuration, wing shape. So another factor is the engine. So if you see the engine parameters, right? So this image which is shown in the upper surface, so that is with Mach number 3 and then Mach number 6 and then Mach number 12. Okay. So Mach number 3 and Mach number 6, this is supersonic. Mach number 3 is supersonic, and Mach number 6, that is hypersonic. Okay. But whereas Mach number 6 is used by ramjet engine, we are using ramjet engine, whereas Mach 12 is scramjet engine. Okay, scramjet and ramjet. So as I'm not going to explain all about ramjet and scramjet over here, right? So kindly give me a second. presentation is visible?
Yes, sir. Thank you, sir. This was an amazing session.
No, no, no.
And hello? Yes, sir.
Yes, dear. I have not completed this session. Wait.
Okay.
Actually, unfortunately, it has.
Yes, your screen is visible.
Screen is visible, right? Because I cannot able to see that.
Yes, it's visible.
Okay. So the variation of engine is like you can see the exit area, nozzle area of the wing and the aircraft. So if you see for supersonic, the engine area is over here, right? Engine is placed, 4 engines are placed over here. But in case of Mach number 6, that's ramjet combination. So if you see here, that is shaded portion is over here. So that is giving us Mach number 6 for ramjet engine. So Mach number 12, the area is required more. So you just see the exit area. I'm just speaking about the exit area of hypersonic aircraft. So here it is very much less in supersonic. At ramjet engine, it is comparing to supersonic, it is more exit area, but in scramjet, it is more than ever required for compared to other type of engines. Okay, so this is turbojet, ramjet, and scramjet. So most of the hypersonic vehicle, this is the exact 2D diagram, nearly 2D diagram of HSTDV also, similar to HSTDV, which DRDO has launched. So if you see the shape of the vehicle, it is not only going to help for propulsion system, it is also going to help for aerodynamic system also. Okay. So in this image, I have represented with two different structures, like two different colors actually represented. One is red color and another one is gray color. So the red color is indicating with propulsion system and the gray color is indicating aerodynamic system. Okay. So apart from that, if you see the shape of the vehicle, it is not only going to help for propulsion or aerodynamics, it is going to help for the maneuverability also. Okay. So how it is going to helpful for the maneuverability? So the design of the vehicle is done in such a way that from the nose to tail section, right, from the nose to tail, we are having various types of ramp. So the ramp is different type of ramp 1, ramp 2, and ramp 3 was petroleum, and inlet, cowlip, and nozzle, and Zen type nozzle is also given. Okay, so Zen type nozzle is nothing but single expansion ram nozzle. So that was mentioned here. So there will be only one expansion. So that's why it is called a single expansion ram. Ram means the shape of that which is inclined, right? The structure is inclined. So this is called as ramp 1, ramp 2, ramp 3. So this is a nozzle, exit nozzle area, right? So the ram is single ram. So single expansion ram nozzle. Okay, the exit nozzle is. So Zen is given over here. So when we are designing a hypersonic vehicle, even the DRDO vehicle will be similar to this configuration. It is designed in such a way that it will withstand the stability of the aircraft, because as I told, controllability is very much important in the aircraft. Okay, so if you see here, the ramp 1 will give a pitch up movement or clockwise movement, so that the vehicle will nose up will be done in the vehicle. So it is mentioned here. So in ramp 2, the movement will be little bit decreased. So it is mentioned over here. And ramp 3, approximately the ramp 3 over here, right, which is mentioned over here in the right hand side image. So it is nearly 0. So what happened? My aircraft, in the half of the session, my aircraft is giving a nose up movement, right? So which is need to be avoided, because if you think, if you are in an aircraft, and if the aircraft is flying with always with a nose up, right, it is not going to fly in a steady level. You cannot walk in the cabin also, right? So that will be worst scenario. So we have to maintain the stability of the aircraft, even though it is flying with a speed of 2 km per second. Okay. So for that, the design was done in such a way that, whereas the Zen nozzle, right? So the Zen nozzle will provide anti-clockwise movement. So there will be a clockwise movement, and anti-clockwise movement will be also generated. Okay, in the structure itself, the four-body structure will generate clockwise movement. After the four-body structure, it will generate the anti-clockwise movement, which you are seeing over here. So by that way, we can maintain the stability of the aircraft. Okay, hypersonic vehicle. So I have used the same design was the same configuration design was done in a hypersonic DRDO hypersonic vehicle. So you can see here the four-body of the section is here and the engine shape is there, and at the exit you can see a single expansion ram nozzle. And if you see in the top surface, top view, you can see there is a double delta wing. From here itself, the wing is starting. From the here itself, the wing is starting and it is coming over here. Okay, from here itself. Right. So in the side view, you can, in the front view, you can see from here itself, wing is starting and it is going over here. Okay. So from here itself. So that's why I have told in the OG configuration and double delta configuration. So the same type of thing is used for supersonic, and they have following it for hypersonic, but span length was reduced. Okay. So the reference I have used here is with Dr. Ernst Heinrich Herschel. So this is the book I have taken for reference of aerothermodynamic design problems in hypersonic vehicle. And I request you also use the same. And I have referred NASA and DRDO's website also. Okay. So thank you. If you have any queries, you can ask over there.
Yes, thank you, sir. This was a wonderful session, and we got a great experience here. And we have some questions from YouTube live chat. So I would like to ask those questions for you.
Okay.
Firstly, we have a question from Manjunath that what happens after an aircraft rollout?
What happened?
After an aircraft rollout.
Sorry, your voice is a little bit. Can you repeat again?
Sorry. Okay. Hello.
Yes. What happened?
Yes, there is a question from Manjunath that what happens after an aircraft rollout?
Roll out.
Yes, sir.
Rolling. He is asking about rolling movement. Okay, so if he is asking about rolling movement, then I can tell that we need to overcome that electronic coupling. Nowadays, we are having an electronic coupling. So if the unexpected rolling movement was happening in the hypersonic vehicle, so the here we are having a flap, a body flap, or we will be calling it as the L1. It is a control surface of the hypersonic vehicle. So using that, we can maintain the stability of the aircraft. Okay, so either it is rolling clockwise or anti-clockwise movement. So using electronic coupling, we can maintain and we can retrieve that to back original position. So that can be done easily. I hope that will be answering for that question.
Yes, okay. There is another question from Neeta Nair that what is maneuverability? Can you elaborate it?
Okay. So the maneuverability. So when you are driving a car or bike, you may be doing like left turn or right turn, right? So some people, if you see sports bike or if you see generally common people when they are driving, they will be driving in different maneuvers, like different manners. So the same aircraft will be also doing. You know, if you have seen some air shows in Bangalore or in any other places, or you can see in YouTube also. So when we are doing this that type of maneuverability, the aircraft will having a rolling movement, it will be having a pitch up or pitch down movement. So especially the movements of the aircraft is said to be the maneuverability of the aircraft. Okay, how the aircraft is behaving, whether the aircraft is moving, banking left or banking right, and various type of other factors also over there. So that also will be these are general movements of the aircraft. It is not about the aircraft also, even spacecraft. General movement is called as manual movement.
Yes, thank you, sir. There is another question from Nadeep that you want to elaboration of critical touch role behavior.
Touch role behavior, yes. See, uh, here for hypersonic flight, this is still under development only. So as that question she has asked, that is good actually. But when we want to do that, we need to do at least some time spanning of hypersonic testing facility, right? Because only 20 seconds we have tested. In that only we have tested for steady cruise level. So if he's an aerospace engineer, she's an aerospace or aeronautical engineer, she knows that very well. We are having a flight path. So if you are in an aircraft or if you are traveling in an aircraft, so generally the aircraft path is from takeoff and climb and then cruise and then descent and then landing. Okay, so this is the general phase. So she is asking is also one type of maneuverability and many stunt like some sports even and all while family sports even they will do this stunt and sometimes it will be occurring in unexpected manner also. So that scenario cannot be it is not yet tested in HSTDV because only we have a shorter time span of testing. So once the testing time speed is increased and they have tested the cruising altitude fully, then they will test with all different type of maneuverability. That will be a later part actually. So we don't have any factors about to explain in the Dutch rule about hypersonic. Right.
Okay, we have another question from Manjunath that is there any upstream influence in supersonic flow?
Is there any
Upstream influence in a supersonic flow?
upstream and downstream conditions? See, there will be a bow shock wave. So nearly when we are speaking about the upper surface, right? So the upper surface will be tends to vacuum. That is pressure will tends to zero. Okay, due to the speed of the vehicle, when it is going nearly that much speed, it is not only for hypersonic cruise and acceleration vehicle. It will be suitable for space shuttle or if it is for any type of capsules which is falling from the atmosphere, right? So that the upper surface, upstream surface will be also going with pressure will be tends to zero. Okay. So in that scenario, we cannot say that there is that upstream will affect the performance. Although there are other disadvantages are there, like shape of the vehicle and other factors are also there. But most probably the upstream will be avoided over here due to the shock wave presence.
Okay, thank you so much, sir. So
Okay.
if you participants, if you have any further questions, I'll request you to ask it in an Insta story. We'll open up a platform to ask your questions, and
Sure thing, sure.
our team will try to answer all those questions, and also we'll try to get it done by Pon Maa Kishan, sir. And now I would like to hand over this session to our founder, Mr. Umang Sudani, to deliver the vote of thanks.
Yeah, sure. Thank you so much, sir. It was a wonderful session with lots of information and facts presented in the very simple manner. And we also got the excellent response from our viewers in the live chat. I want to show all my thanks and warm gratitude to Pon Maa Kishan, sir, and for sparing us apart from his most valuable time schedules. Thank you so much, sir, for delivering this lecture in the very simple manner. We are looking
Thank
forward
you.
in the future for the more webinars from you. Thank you so much,
Thank
sir.
you, dear.
It
Thank you.
was a
Thank you.
great.
Thank you, dear. Thank you, dear. Thank you for the team who has invited me for this wonderful session, and also